Okay, in the last couple of sessions, we discussed about how AML work and what are different applications and looked into them. In the first two sessions, we discussed different aspects of artificial intelligence and machine learning and got a introduction to those two. And then in the last session, we had a high level overview of speech recognition and applications like ASR and text to speech. So this session and for the next couple of sessions, we will look into natural language processing and different applications in it. So when we look at natural language processing, there can be multiple levels of processing. So as the name suggests, natural language processing means processing natural language. So programming languages are like Python, C++, etc. Natural language means the human language, like languages which we speak and write, etc. If you take any sentence like I'm teaching this class, so there can be analysis at word level, sentence level, and discourse level, which is basically a text level. So we will look into multiple processing steps in at word level, sentence level, and discourse level, and discuss some of those concepts here. Again, as the word suggests, word level processing basically means we will analyze the word and try to get some information out of that word. The basic and word level processing thing is morphological analyzer. So morphological analyzer basically means it takes the word and tries to identify morphological information like what is the root of the word, what is the gender, number, person, tense, etc. For example, if you take word like reading, so I'm reading a book kind of word. So reading is a continuous tense verb, right? So if you take the word reading, the root form is read. So if you take read, and if you add present continuous form, it will be reading. If you add past tense form, it will be read. If you add present perfect form, it will be like have read, etc. Similarly, if you take eat, continuous tense will be eating, past tense will be ate, present perfect will be have eaten, etc. So the root form is read here, and gender is neutral because we are not specifying any gender for this word. So for some words, there can be gender information. For example, if you take nouns, Ram is a masculine gender word, whereas Gita is a feminine gender word. Number can be anything here because it can be used for both singular number as well as plural number. So I am reading a book, he is reading a book, they are reading a book. So based on the number, the word doesn't change. Similarly, person, like for first person, second person, third person, we can use the same word. The auxiliary verb like am, is, are change, but the main verb of reading doesn't change. And the tense is present continuous tense here. So this kind of information can be useful in multiple applications, and this is like a basic step in text processing. So for example, if you take sentence like I read books versus I read a book yesterday. So if you look at the morphological analysis, for read, we will have present tense, whereas for read, in the second sentence, READ, we will have past tense. So in both the cases, the script is same, like we are writing READ and READ. Based on the tense, we can, based on the tense, the pronunciation of that word changes. Right? In the first case, it is I read, whereas in the second case, I read. So that's one example of where these fine grained details can be useful. Other example is when we are storing these words in computer, especially for agglutinative languages like Telugu and most of the South Indian languages. So the suffix form gets added to the word, and sometimes it transforms the word, and or it can be present as a suffix to that word. For example, if you take Hindi, in Hindi, most of the suffix happen as a separate word. For example, if you take go, in English we have like go, going, went, gone, etc. In Hindi, the word like ja, which means go. So ja is present as a separate word. Ja raha hu, which means I am going. Continuous form of it. जाते हैं, जाऊंगा. So in majority of the cases, the suffixes or the inflection is a separate word. Whereas if you take Telugu or any other South Indian language, these suffixes or the information is added to the word and is part of that word. So, for example, if you take the word ja itself or go in Telugu, the root form is వెళ్ళటం or వెళ్తున్నాం. సో వెళ్తున్నాను, వెళ్ళాలనుకుంటున్నాను, వెళ్ళాను, వెళ్తాను. So all these are single words, and based on the tense and aspect and modality, the form of the word changes. So in a way, you take the root form, and based on the morphological inflections, the root form is transformed into some other word. And for each of these words, we can have rules and generate all the inflected words. That way, when we are saving these words in a computer, we can have the root form and add the corresponding tense aspect modality information as a separate thing, so that we don't have to specify each of those tokens in the system. Okay, and these gender number person will also help in agreement. So, for example, in English, there isn't much agreement between verb and the subject. For example, you take the same word like go, I am going, he will go, she will go, etc. So he will go, she will go, they will go. So based on the gender and number and person, it's not really changing, right? Whereas in Hindi or in Indian languages, the inflection of the verb changes based on the subject. For example, in Hindi, मैं जा रहा हूँ, वो जा रहे हैं, जा रही है, if it is female. Similarly in Telugu, నేను వెళ్తున్నాను, అతడు వెళ్తున్నాడు. So we'll add like the do form if it is in masculine. ఆమె వెళ్తుంది. We'll add the the form if it is feminine. And if it is plural, వాళ్ళు వెళ్తున్నారు. So that way we can get the morphological information of the subject and morphological information of the verb and see if there is agreement or not. If there is no agreement, then there is some mistake in the grammar of that word. Okay. So this is one of the basic steps at word level. Like we take the word and try to understand grammatical aspects of that word in isolation. What is the root form of that word? Gender, number, person information, and tense aspect information. Mhm. So the next topic is parts of speech tagging or keywords tagging. So most of you would know parts of speech tags. Like when you learn new language in high school, primary school, the first thing is the teachers will teach us partial speech tags for each of those words. So this is very basic step in the text processing, and it has multiple applications. So any processing after the word level will use parts of speech tag as a useful information, and we can do processing on top of that. So for example, if you take something like I am going to Hyderabad, I is pronoun, am is auxiliary verb, going is main verb, to is preposition, Hyderabad is proper noun. Similarly, if you take I ate an apple, I is pronoun, ate is past tense verb, an is determiner, and apple is common noun. Okay, so for parts of speech tagging, it doesn't need a lot of introduction because everyone has gone through parts of speech tags during their schooling, and that is native language or English or other things. And as I said, parts of speech tagging is the very primary step, and any further processing or any further applications on text use parts of speech tag as a feature, and it helps in the upstream tags. So next application is chunking. So chunking or phrasing is nothing but to take the sentence and group them into meaningful groups. For example, if you take I ate an apple, I is a noun phrase. So noun phrase consists of a pronoun or a determiner followed by a noun. Similarly, an apple is a noun phrase. And ate is a verb, and ate followed by a verb phrase, ate followed by a noun phrase is called verb phrase. So this kind of chunking helps in checking the grammar of the sentence in majority of the case. For example, if you take a simple sentence would have noun phrase and a verb phrase, and verb phrase will have verb followed by a noun phrase. And noun phrase can be proper noun or determiner followed by a noun, sorry, or another thing like determiner followed by optional adjective followed by a noun. For example, it can be like I ate a big apple or a small apple. So that adjective can be optional. So so that way you can design grammar for a language and see if the sentence falls within that grammar. And if a sentence falls within that grammar, then you can say that the sentence is a grammatical sentence and a meaningful sentence. Again, here the terminal nodes are parts of speech tags. So I is a proper noun which is PR represented by PRP. Ate is a verb which is represented by V. An is a determiner which is represented as DT. Apple is a common noun which is represented as N. So you take the parts of speech tags of each word, so, and based on that, those parts of speech tags, and using the grammar, we form chunks and form a sentence. And if you can form a sentence out of this, then it is a meaningful sentence. And if you can't form a sentence out of it, then there is some grammatical mistake here. And using that information, we can identify what is the correct grammar here. Okay. So the next application is named entity recognition. So named entity recognition is nothing but identifying some entities within the sentence. For example, Ram is going to New Delhi. Here, Ram is a person name, New Delhi is a place name. In the second example, Raja Ram ordered food from Domino's. So Raja Ram is a person name and Domino's is organization name. So in named entity recognition, these three are the most common entities we recognize. So person name, place name, and organization name. So these three are some of the important tags, and this helps in identifying named entities. And named entity recognition has multiple applications. First of all, it helps in identifying the names of cities, persons, and organizations, and especially if it do some application like machine translation. In machine translation, when you're translating a sentence from one language to another language, in majority of the cases, we don't want to translate the named entity. We just want to move it from one language to other language. Maybe if there is a script conversion, we need to do the script conversion. But we don't want to translate that phrase or word, which is a named entity. So in the initial examples, we saw that few problematic cases in Google Translation. Right? So when we say my name is Pandana, so treating instead of treating Spandana as a named entity, so Google Translate treated it as a common word and translated Spandana into response. So instead of my name is Spandana getting translated Na peru Spandana, it is translated as Na peru response. The other way. So Na peru Spandana is translated to my name is response rather than my name is Spandana. Okay. So that way, if you can tag named entities, then in the later applications, you can use that information and do appropriate processing compared to other words. So I said person name, place name, and organization name. So these three are the most important named entities. There can be other minor named entities like time expressions or currencies, etc. So that's high level about the word level processing. So now let's look at the sentence level processing. So one of the most common and most useful applications at sentence level is sentiment analysis. So for example, we take a sentence like I like the movie. So here it's a positive sentiment. Right? Whereas if you say I don't like the movie, so here it's a negative sentiment. So in sentiment analysis, basically we take the sentence and try to identify whether it is a positive statement or negative statement or a neutral statement. So if it is a sentence like I saw the movie, then there is no positive sentiment or negative sentiment in it. We are just saying that you just saw a movie. So in that case, the sentiment would be neutral. So in sentiment analysis, these are the three major types: positive sentiment, negative sentiment, and a neutral sentiment. And this information is useful in a lot of applications. So for example, you have some product and you are getting reviews for that product. So you can apply sentiment analysis on the text and categorize those phrases and see how much positive sentiment you have for the product versus how much negative sentiment you have for the product. Say you got 1,000 comments on a product, and out of that, 90 of them are positive, 5 are negative, and 5 are neutral. Then you can say with high confidence that it is a positive product. Similarly, for movie reviews, you saw a movie review and there is a lot of text, you can categorize the text and identify whether it is positive sentiment or negative sentiment. If there are a lot of positive statements, then you can say the movie is good. But if there are a lot of negative statements, then you can say the movie is not so great. Okay, so that's basically about sentiment analysis. In sentiment analysis, we take the sentence and identify whether it is a positive sentiment or negative sentiment or neutral. And One of the most complicated sentence level processing is syntactic parsing. So syntactic parsing, there are two kinds of parsing which are mostly used. One is called phrase structure parsing, another one is called dependency parsing. So in phrase structure parsing, you take the sentence and try to form a tree out of it. So this is similar to the grammar example which I gave using chunking. So you have the grammar. So for example, here the sentence is John hit the ball. So at first level, we identify parts of speech tags for each word. So the is determiner, ball is a noun, hit is a verb, John is a proper noun, and which can be a noun phrase on its own. So once we have the parts of speech tags, using the grammar, we can form phrases out of it. So a determiner followed by noun can be a noun phrase. Similarly, a proper noun or a person name or a pronoun can be a noun phrase. And a verb followed by a noun phrase is called a verb phrase. And a noun phrase followed by verb phrase can form a sentence. So this helps in identifying the structure of the sentence so that we can process it and do any further processing on top of it. So we'll go into details of syntactic parsing in the later slides, in the later sessions. But at high level, the phrase structure parsing tries to form a sentence out of the given words. And if you can form a sentence, then it's a meaningful sentence and have some structure to it. If you can't form a sentence, then it's not a meaningful sentence. And again, using the phrase structure, we can parse, we can identify subject-object information. So for example, if you take a sentence, the noun phrase to the left of that sentence is subject. And if you take the right hand side, go to the verb phrase, and the noun phrase within the verb phrase is the object. So here, John is the subject, and the ball is the object, and hit is the main one. So we can have such rules, and based on the sentence structure, we can identify what is subject, what is object, and do the translation accordingly. For example, if you take machine translation application using phrase structure kind of analysis, so you take the phrases and translate at phrase level. So you take the ball and translate it into the corresponding word in the target language. For example, take John hit the ball. John Bantini kottadu. So the ball as a phrase is translated to Bantini rather than just the ball and the separate entities. So other form of parsing is dependency parsing. So phrase structure parsing is really useful when we have structure to it, like the sentence should have subject, a noun phrase followed by verb phrase, etc. Whereas in dependency parsing, we don't really look at the phrases, we directly look at the words and try to identify the relationship between words. So if you take the same sentence like John hit the ball, here hit is the main verb, which is the head of the sentence. And for this sentence, John is the subject. So we mark John as a left hand side with subject label. And the ball is the object. So we mark ball with object label. And for the ball is the head and the is determiner. So that way we can identify subject, object, and other grammatical relations within the sentence. So again, this is similar to the grammar 101 which we have in our schools. So given a sentence, trying to identify what is subject, what is verb, and what is object kind of relationship is nothing but dependency parsing. Again, parsing kind of uh, thing can be used for applications like machine translation or question answering, etc. For example, if you take sentence like John hit the ball, and if you take sentence like who hit the ball, and if you draw the graph for who hit the ball, so the graph will look exactly the same, and instead of John, we'll have who. So based on that, you can match both the graphs and extract that John is the replacement of who, and you can answer it as who. Similarly, when we are translating from one language to another, based on subject, object, verb, so the ordering changes based on some of the languages, right? In English, it's subject, verb, object language. Like John hit the ball. Whereas most of the Indian languages are subject, object, verb, final languages. So John, ball కొట్టాడు. John ने ball को मारा. So subject will come first, object will come next, and then the verb will come. So based on that information, we can translate at phrase level and reorder them to form correct word order. So this is an example at sentence level. So now let's look at discourse level processing. So discourse level processing is basically beyond sentence level. So here we saw some examples at sentence level like dependency parsing, etc. Right? Now, when we look at the discourse level processing, we look at previous sentence or sometimes entire paragraph or entire page in the context. For example, one example is anaphora resolution. So anaphora resolution is trying to identify what the pronoun means and try to get the corresponding entity. For example, if you have sentence like Ram is going to Hyderabad, and the next sentence is he will take a train in the morning. So when we see the sentence based on the previous sentence, we can identify that he means Ram, right? Similarly, if the sentence like he will take a train to go there. So if you look at the sentence, if you look at the sentence in isolation, we don't know what he is and where he is going. Whereas when you look at the sentence in the context of previous sentence, so we know that he corresponds to Ram and there corresponds to Hyderabad. So if you want to make this sentence in isolation, you can replace it with the corresponding nouns and the sentence will become Ram will take a train to go to Hyderabad. So this is called anaphora resolution, trying to find the pronouns and identify pronouns and the corresponding nouns which are related to these pronouns. So another example which is at discourse level is text summarization. So text summarization is nothing but you take a piece of text and try to identify key points out of it and give some summary on. So for example, you have a 500 line text or say something like 20-line paragraph. And if you want to give one headline or couple of one or two lines, which is gist of the paragraph, then we use text summarization. So text summarization is used for most of the news applications. For example, if you go to Google News app or some other news app, you see like one or two lines at the top, which gives you summary of the what that article is in addition to the title. So based on those two, three lines, you decide whether you want to go in deep to the article and read deep or just skip it. So text summarization basically gives you a high level view of the content in the text so that you get the gist of it rather than reading complete text. Okay. So these are different levels of processing: word level, sentence level, and discourse level. So as I said, the word level processing, morphological analysis is one of the basic steps. You try to identify morphological features like what is the root of that word, what is the gender, number, person, etc. of the word. And this information can be useful in the downstream task like identifying the tense so that we can pronounce the words correctly. etc. And one of the most common and most basic tasks at word level is identifying parts of speech tags. If you take any text, parts of speech tagging is the basic task, and having a parts of speech tagger for your language helps in developing tools on top of it. So, and another important application is named entity recognition. So, given a text, we identify the entities, like what are the person names, what are the place names, and organization names. And using that information, we can do some downstream processing. Say, for example, we talked about sentiment analysis. Right? So, we have 10 different articles, and each of those articles, yeah, each article is talking about one organization. So, and the corresponding places in that organization is present. So for example, we have a review for Domino's in Hyderabad, Domino's in New Delhi, Domino's in Vijayawada, etc. So the sentiment need not be same across the cities, right? So you look at the feedback on each of those places. So you have three separate files, and in one file you have feedback for Domino's in Hyderabad, and in another file feedback for Domino's in New Delhi, and third file you have feedback for Domino's in Vijayawada. So using name entity recognition, you can identify the place names and the organization names so that you can populate that information and highlight that. And using sentiment analysis, you can identify whether the reviews are positive or negative or neutral, and provide some statistics on that. So this way you can combine multiple tasks and create your own application and provide some meaningful feedback. And at sentence level, one of the most important tasks is phrase structure parsing and dependency parsing. So parsing is nothing but given a sentence, you want to identify subject, object, and verb information at high level and other minute details. So this syntactic parsing helps us in identifying grammatical labels, and also helps in downstream tasks like machine translation and question answering. So machine translation and question answering can also be treated as sentence level processing tasks. So you take sentence like John hit the ball and you translate it into another language like John ball ni kottadu. You take the English sentence and translate it into Telugu sentence. So that is also an example of sentence level processing. Similarly, question answering can be another example at sentence level processing. So John hit the ball is a sentence, and you ask a question like, "Who hit the ball?" And based on the sentence, you can identify like John is the answer for it. And when we talk about discourse level processing, we do analysis beyond sentence level. For one example is anaphora resolution, where we identify pronouns and try to match it with the corresponding nouns in the previous sentences. Similarly, another example is text summarization. We take a big chunk of text and summarize it into few words or few phrases and sentences. Okay? So this is high level about different NLP tasks and how the text processing happen. Again, in these sessions, I won't be giving the gory details of each of these applications. So I'll give you like high level view of what are different terminologies in this section, and so that you can go back and read corresponding things on Wikipedia or some other places. For example, if you want to know more details about name entity recognition. So name entity recognition is a popular task. There are Wikipedia articles as well on it, so you can go to Wikipedia article and study in more detail, like what are the different tags in it, and what are the different ways of doing it, and are there open source tools available for it, etc. Okay, so that's it for today. And in the next week, we will look into one of these applications and go in more detail. Okay, thanks everyone.